Hi. So I'm going to be sharing this lesson with you guys just on video today. So I need you to make sure that you have your trays, make sure that you have your notebooks, everything else as usual. So give you a second to get settled here as I pull up the screen from yesterday. All right. So yesterday I left you with this problem here. And I said I have two samples of salt water. All right, so two samples of salt water. Sample one is 45 milliliters and its mass is 54 grams. Sample two has a lot more volume, 120 milliliters, and its mass is 132 grams. So, which sample is more dense? And I had asked you to think about which one would be more dense just by looking at the problem itself. Okay. So, a lot of you thought 100 the 120 sample number 2 might be because the numbers are bigger, and that makes perfect sense. But remember that density is a ratio, meaning that I'm going to be dividing my mass divided by my volume, and this is the shortened abbreviation of it here. D equals m over v. And so you have this page in your tray, so I would like you to find it and glue this in right below it. All right. So it looks like this. You should have it in your tray. It's a little bit longer than that. Let's see, it kind of goes like this here. So give you a second to glue that in. So as you're seeing on this page here, we have the density equation. It's always mass divided by volume. Okay. And I can see my calculations here. So D1 is density 1. All right. I have my mass and my volume. And then in parentheses, I have the units here as well. So I know what units belong in those parentheses. So the first one, this is sample number 1, was 54 grams. That was the mass. Right up here, it says the mass of sample 1 was 54 grams. So that goes on top. Be careful that you're not putting 45 on top just because it was listed first. 45 milliliters. Milliliters is a volume. Mass is measured in grams. So mass, my grams always go on top. So 45 grams divided by 45 milliliters. When I divide that, I get, after I round, I get 1.2. My units are grams per milliliter. And so you have that slash symbol there. You read that like per, like miles per hour, all right, is written kind of like this. So miles per hour, we read that as grams per milliliter. All right. I have to include both of my units in my answer because they don't cancel. So sample 1 is 1.2. Sample 2, if I take its mass, again, looking at the problem, it said it was 132. Careful that you don't put 120. And divide that by 120 milliliters. Since I'm dividing these two, I get 1.1 grams per milliliter. So now, as you can see, there is a difference in density, even though it's small. But I can see that my first sample is more dense. So I'd like you to write that next to it. So sample number 1 ended up being more dense. So remember that you really can't use the original mass and volume to help, to guess your density because you're going to be dividing them and whether you have 4 out of 4 or 10 out of 10, your grade is still 100%, right? So it doesn't matter how many you started with, your ratio is still the same. So then it says the question to ask yourself is, what is the mass of 1 milliliter of the solution? That's essentially what density is. So per milliliter means like per 1 milliliter. It means that there's 1.1 grams in there. Now you're going to see grams per milliliter or grams per cubic centimeter. So you see right here where it says cubic centimeter. We also have another way that we write our volume measurement, and that is cubic centimeters. So we write it like this though. Actually, I'm going to put it so grams per cubic centimeter. The word cubic means to the third power, and centimeter is a centimeter. Okay, we'll discuss this more here in a little bit. So then it says to find out, divide the mass of the sample by the volume. We saw that was done. So another way to think about density is, I know the mass of 45 milliliters of this solution. 1/45th of the sample, or 45th, sorry, 45. 45th of the sample is 1 milliliter. So to find the mass of 1/45, I divide the mass by 45. I don't know if that would help you think about this in a different way. Just essentially think of this as I want to know what is my ratio of mass to my volume. Okay. So then I'm going to have you take these notes. If you need to move on to the next page, you can. You kind of want to have all these together. There's probably about 10 lines worth of notes for you to write. So if you want to move these on to the next page, that would be fine. So mass, we have talked about in here quite a bit. It's how much matter is in a substance. So that's going to be a vocabulary word. So make sure you grab your highlighter and highlight that. So mass, the amount of matter in a substance. And to find the mass, I would need to use a scale balance to get that. All right. So the same ones that we use in here, that's how you get the mass. All right. The units that I'm going to be measuring my mass in here are grams. Okay. So grams, lowercase g, when you are abbreviating it. So lowercase g when you're abbreviating it. So mass is always measured in grams. We won't use any other units in here. The volume is how much space an object takes up. Again, highlight that. How much space an object takes up. So how much three-dimensional space does it take up? Now, volume we can measure in a couple of different ways because it will depend on the reason that volume is going to have two possible units here is because there's different ways to measure volume based on what the object is. All right. So we have solid objects and we have liquid objects. And gas as well. I can use a couple different methods to measure volume, and some work better for, solids, and some work better for liquids. All right. So the two ways that I really can measure volume are by either using a graduated cylinder. That's what I was showing you yesterday, the graduated cylinder. or I can actually measure the volume of an object using a ruler. Now, the ruler doesn't always work, especially for objects that are not like box or rectangular shaped. But for now, we'll just stick with that, and we can always talk about another way to measure volume a little bit later on. So because I have two different ways to measure, the graduated cylinder I use for liquids, the ruler I would use for solids, I have two different possible units. So if I'm going to be measuring in liquids, or if I'm measuring a liquid, sorry, then my units are milliliters. Make sure you write the word liquids in parentheses. So you have milli, that's like a prefix, and then liters. When you write it as the abbreviation, it should be a lowercase m, not a capital, and then a capital L. Now, if I want to measure the volume of like a tissue box, well, milliliters doesn't really make sense, right? Like how much space is the tissue box taking up? Doesn't make sense to measure the volume in milliliters. It's not a liquid, so it's not going to form to the tube. It's not going to go into the graduated cylinder. So for solid objects, I use cubic centimeters, which is what I had you write down at the beginning. Now, hopefully this sounds somewhat familiar to you. I'm sure you would have actually talked about cubic centimeters in math before. So it's a cm, both lowercase, and then it's to the third power. Sometimes you can say this as centimeters cubed, and that to me makes a little bit more sense because that's the way you write it. So centimeters and then cubed. But you should have the word cube in there somewhere because cube tells me that there was 3 measurements taking. And I need all 3 measurements if I'm measuring volume. So where would that come from? Well, you're probably familiar with this equation. The volume of a rectangular object is its length times its width times its height. All right, so if I have the volume of a rectangle or a tissue box or a book, something where it has nice square edges, and I want to know the volume, I measure the length of it, I measure the width of it, and then I also measure the height. So you're probably, like I said, familiar with that equation there. Go ahead and write that down underneath the cubic centimeters. So that's where the volume or the cubic centimeters comes from. So when you have a number and it says 45 cubic centimeters, it came from some former version like this. Now, not everything is going to be rectangular shaped. And so we have different ways that we can record volumes though. So now that I know the units that I'm always going to be using when it comes to mass and volume, here are my density units. So I'm always going to have grams on top. Okay, grams will always be on top. That will not change. I'm not going to use anything else but grams. If I'm measuring the density or talking about the density of a liquid, like salt water or oil or just water, I'll probably want to use these units, grams per milliliter. But if I'm talking about the density of a solid object, like gold or a rock or a tissue box, then I'll want to use grams per centimeter cubed. All right. So I'm going to continue on with our next page here that we're going to work on. So that would be this one here. Make it full screen. So if you should find this in your tray, and I will give you a minute here to glue that in. Same title. Go ahead and do all that. Okay, if you need more time, you can have the video paused here. Otherwise, we're going to move on. So it says on the very top, calculating density of layers. So we're going to jump back to, now that we know the formula for calculating density, and now that we've done a practice problem, we're going to calculate the density of the layers of the different colors that we had in the lab. So the first thing there says, write the equation for calculating density here. So that is D equals M over V. Then it says transfer the mass and volume data from the board into the table below. And then we're going to calculate the density of the 4 solutions. Remember, the solutions are the different colors that we use. All right. Now, I'm just going to write them up here as far as the mass and the volume goes. These were the numbers that you wrote down yesterday in that little table for part 3. So these are the same ones as that you wrote down yesterday. So the red was 25.0 grams. And remember, the volume was 25 milliliters, and that was for all of these. Remember, all of the samples that I had done were all exactly 25 milliliters. All right. So the red weighed 25 grams. Now it does say 25.0. I'm going out 1 decimal place because that's what it says on my scale. So I want to include that. Green was 26.5. 26.5 grams. Yellow was 28.2. 28.2 grams. And the blue was 30.0 grams. All right. So I've transferred the mass and the volume from the from that part 3. Then it says calculate the density of the 4 solutions. Show your math work and then solve the density problem at the bottom of the page. All right. So you are going to, over here on the side and below the chart is where you can show your work. I want everybody to show their work. I'm going to do the first one with you, and then I want you to do the next 3 on your own. So I'm going to title this one over here red, okay? Because I'm going to have 4 calculations. So I want to make sure that I know which one is which. So I'm going to type it, I'm going to write red over here. And then I'm going to write my equation, D equals M over V. All right, now it's just simply plugging in my numbers. Okay, so my red was 25.0 grams. So 25.0. And I'm dividing that by my volume, which is 25, and then I always want to include my units, so that's milliliters. All right. Now, when I do 25.0 divided by 25 on my calculator, I actually get 1. And I'm going to go ahead and go out to 1 decimal place because that's what that one does. Okay, so 1.0, now I need to figure out my units. My units are grams per milliliter. Okay, so my answer for red is 1.0 grams per milliliter. I'm going to put that density over here in the chart, 1.0 grams per milliliter. All right, so now I would like you to take some time. I'm going to have the instructor pause your video here so enough people get some time to get most of these done. I need you to figure out the density for green, yellow, and blue. Set it up the same exact way. The only thing that's different is your mass each time, but everything else is the same. All right, make sure you put your density over here on the chart. Just go out to 1 decimal place like I have there. All right. So go ahead and pause the video here to give yourself some time to work through those 3 other problems. All right. So now underneath here, we have this information. Sorry, let's go back. I don't want to put the numbers down here right away because I want to make sure everybody was able to do their own work. But I would like you to share your numbers that you got with a table partner or somebody across from you just to see if you got the same numbers. Okay. So I may have originally told you just to go out to 1 decimal place, but that may not have actually been enough just to see the differences. So with the green one, when you take my calculator here, so when you take the 26.5 divided by 25 milliliters, you get 1.06. So that's the number that I actually want to see for green. Okay, 1.06 grams per milliliter. Yellow should be 1.13. And our blue should have been 1.2 or 1.20. All right. Now, as we probably predicted, right, the whole time that we've been talking about density and talking about why the layers layer the way that they do, we've been saying that the blue one is the most dense because it's on the bottom. Well, we've mathematically proven now that it is. 1.2 is bigger than all of these. All right. And so they'll all layer this way here because they layer on top of each other based on density. All right. So you have a couple other questions here on the bottom. Let's go ahead and try these. So it says 2 students mixed up a new salt solution and put it in blue and red food coloring to make it purple. So they basically made a purple salt solution. They weighed 35 milliliters of the solution and found its mass to be 41 grams. Where would the purple layer form if it were used with the 4 solutions above. Show your math. Okay, so what I want to do is I want to figure out, using these numbers here, what is the density of my purple layer? Okay, so let's work this out. So purple, and I'm going to use my same equation, D equals M over V, mass over volume. All right, reading through here, make sure you're doing this right. So the mass of the purple solution is 41 grams. Again, you might, wonder, well, the volume's not the same, right? This volume is 35 milliliters versus we did ours with 25 milliliters. And it won't matter because these are just ratios. I could have measured 50 milliliters of all those solutions and I would still end up with the same density. I could measure 100 milliliters of all of those solutions and I would still end up with the same density. Density is a ratio of those numbers. So you basically are just like getting their smallest form when you divide them. All right. So my initial mass and volume really does not matter. So 41 grams on top. My volume, I'm going to put down here, is 35. Okay. So 41 divided by 35. I get this long number here, and I'm going to round this to the 2 decimal places, so that should be 1.17. And my units are the same. .17 grams per milliliter. Okay. Now, down here, it's asking me what the density of my purple solution is. I'm just going to kind of write that number down here again. I showed it up there, but I'm just rewriting it. Okay. And then the last question says the purple solution would form a layer. So my original question says, where would the purple layer form if it were used with the 4 solutions above? Okay, so I'm looking at this 1.17. Go ahead and look at your numbers here. So you got 1.0, 1.06, it's bigger than that. 1.13, it's bigger than that. 1.20 is our blue one. It's not bigger than that one. So that tells me it should be between my blue layer and my yellow layer. That would be the only place that it would go. So the purple solution would form a layer between yellow and blue. So my colors would be from the bottom, blue, purple, yellow, green, red. All right. Okay, so I think what I'm going to have you do is glue these, this page in. This should also be in your tray. And just work on these questions. You can work on them together. You can work on them, with any of your table partners or by yourself. And these kind of go along with some of the questions from, like, they talk about stuff from our layering lab. They're just kind of general density questions, just, discussion of stuff that we've talked about so far to formulate your answers here. All right, so this will be due for tomorrow. I'd like you to have this done for tomorrow, and I should be back by then. Okay. So use each other, ask each other if you have questions. Otherwise, I'm going to stop here.